Hello everyone.
Hello.
Can you hear us? Don't hesitate to write in the chat if there is any problem with the sound. Let's get started. Hello everyone. Thank you for joining this webinar. So I'm Thomas Galland. I'm working at Kitware in the scientific visualization team, and I will be your presenter today. With me is Lucas.
Yes, thanks, Thomas. I am Lucas. I'm also a software engineer at Kitware, and I also working in the same team as Thomas. I'm here today to assist him during this webinar, and also to interact with you. So if you have any question or any feedback that you want to share with us about current topic, don't hesitate to write them in the chat. The chat should be available. It should be at the bottom right of your screen. And if it's not the case, you may just need to refresh the page.
Yeah, so don't hesitate to ask questions during the presentation, and we will respond to them as long as we are doing the presentation. So let's get started. Today we will talk about advanced rendering with ParaView. But before beginning with that, I will do a little presentation of what we do here at Kitware. So at Kitware we work on different areas of expertise, like computer vision, data and analytics, scientific computing, medical computing, and software solutions. We work on open source solutions that can be developed on different platforms. So they are available on desktop, on web, on mobile, and on HPC. For example, ParaView, that is a good example of HPC application. And among the applications that we develop, we have ParaView that we will talk about today, but also 3D Slicer, VTK, and CMake that can be interesting for developers among you, to name a few. At Kitware, we also offer different services that can be training. So, for example, if you want to know how to use ParaView, we can provide training for that. If you have a question about particular use case using, for example, ParaView or other software, we can provide support. So we have a dedicated service desk for that. We can also do development for you. That's what we do every day at Kitware. So we can, if you want a specific plugin, for example, for ParaView or etc., we can develop that for you. And we also do grant collaboration on European project in collaboration with universities. So just before we get started, let's talk a little bit about what is ParaView. I think you already know that, but I will explain it quickly. So ParaView is an open source cross-platform data analysis and visualization application. It allows you to explore and post-process your simulation results and to generate visualization to extract salient information building pipelines of filter, for example. And today we will focus on rendering techniques that ParaView can provide, and especially ray tracing capabilities of ParaView, focusing on the OSPray, Intel OSPray rendering engine. To put a little bit of context, in ParaView we have two kinds of rendering technique. We have shader-based rendering techniques, so maybe you're already accustomed with that. So we have the standard rendering techniques that we use, for example, to color our data depending on the value on the surface of our objects, etc., or to represent volumes with a GPU-based rendering technique. We have also most realistic ones that simulate the light interaction with materials, that it's called PBR, so for physically based rendering. So this is one kind of rendering technique. The other type is ray tracing rendering. So in ParaView, we have several engines that are available with it. So we have NVIDIA Optics or NVIDIA Index that are based that leverage the power of your GPU in order to perform ray tracing and have very realistic rendering of a big volume of data. And we have also OSPray, so it's developed by Intel. And one advantage of OSPray is that it doesn't really need to have a GPU in fact, it can run on CPU and on some GPU developed by Intel. So it can very be useful to be executed on clusters of HPCs that doesn't have a GPU, for example. So we will focus on OSPray during this presentation, and we will show you how to enable it in ParaView and how to use materials. So we will explain later what are materials, but in short, there are properties that describe your surface and then that allow you to do realistic rendering of your data.
Just maybe one little question.
Yeah.
Regarding all of these different backend. Do you know if all of these backend are also open source, like ParaView, or not?
Yeah, it's a very good question. So as far as I know, Optics and NVIDIA Index are not open source, but OSPray is. Maybe I didn't precise that OSPray is open source as well, so it's a good point. So let's continue with a little demo in ParaView. So I will just swap the screen to show ParaView. All right. So you should now see ParaView with scene that we already loaded to show you. So this data is a calculus simulation done with OpenRadioss. OpenRadioss is a simulator for highly dynamic events, and is an open source version of Radios that is developed by Altair. So it allows us to show you this cool data to you and to introduce OSPray rendering capabilities of ParaView. So first of all, if you want to enable OSPray and rendering ray tracing in ParaView, you will have to go to the view properties. So here, if you click on the view, you go in the view section, you will have a button that is called enable ray tracing and allow you to enable the ray tracing rendering. So we already see a difference. We can see dark shadows on our data that is possible with by simulating the ray that are cast from the camera and from the light source and can show your shadows. So there are two backends available with OSPray. So we have the OSPray Raycaster, so it's the simplest one. So we can see that we don't have so much difference except with dark shadows. And we can also select OSPray Path Tracer. So I will select it. So it can take some time at the first for the first rendering to occur, because this is a more complex mode that will really simulate the ray directions and bounces between the surface to accurately simulate and do real rendering.
Just Thomas,
yeah.
One question: which version of ParaView do you use for this demo?
Yeah, so for this demo, I use the latest release candidate that is named ParaView 5.12 RC2. OSPray is already available in the previous versions of ParaView, so I think 5.11 is already okay. But I choose this one because we have a new version of the material editor that is available in this version of ParaView, and I will show you this version of material editor just after the presentation of ray tracing capabilities of ParaView. So that's cool. We have already an image, so we can see that there is a lot of light, but we will correct that. So next, so just to talk a little bit about parameters that are available with OSPray Path Tracer. So we have some. The most important to take care of are the samples per pixel and progressive passes. So it's different way to choose how many rays are cast to simulate the light travel and to simulate it to obtain a good rendering. So samples per pixel is simply the number of rays that are cast at each render pass. More ray you have, the more the image is defined, and you will have less noise and a more realistic rendering. So here, next thing that we will do is to enable environment lighting in order to build our scene and have a better looking rendering. So here we have just single color, but I can select an image. So I will select this one, and if I move the camera maybe this way, we can see here we have our background. So there are a lot of light, so I will disable the light kit in order to just have the light that is produced by the environment. So yeah, and so the rendering here is not very good because we do not have already enabled any material. So we will go on that now. So what are materials? So materials in OSPray are parameters that you will attach to your surface of your objects, and will describe how the light interacts with the surface in order to do realistic rendering. And this is in the display section because you can attach materials on each actor of your scene. The view parameters are more general parameters to all the view, and display parameters are applied on each actor. So let's select the whole car for now, just to show you how to apply materials. So if I scroll down, I can see here a ray tracing section. When I can select materials, so be careful, you have to have the advanced properties enabled to be able to see the material section. So here I will select materials just to show you. So all these materials are default materials that are available with ParaView in the binary of ParaView. So you will have access to it if you don't just download ParaView. So let's select, for example, silver flat material. So yeah, here we can see that we have nice silver like material on our car, and here all the car looks silverish, but it's just to introduce you to materials. And you can see that we already obtained a good looking realistic rendering of metallic material. So I applied this material on all the car, but now let's show you how to what we can do by applying different materials on different parts of the car. So before that, before doing the presentation here, I already separated different parts of the car just to apply different materials on it. So I will show that to you right now. So let's select the different parts in the pipeline and show them. So it can take a little bit of time.
We also have one question about your actual ParaView configuration. Team asked since when we can display tab instead.
Oh yeah, it's a good question.
Instead of finding it in the property tab.
Yeah, it's a good question because it's not by default in ParaView. In fact, I find it more clear for me to have separate type for different kind of properties. So to have this kind of display, you can go to Edit Settings, and here you will, for example, type Separate, and you have a property panel mode that can allow you to have separate panels for each type of properties. So you can separate properties display and view properties in 3 different tabs with this one. I think you will have to restart ParaView in order to this setting to take effect, but yeah.
And do you know since when this new settings is available or not?
As far I don't know, but I think it's at least 5.10 or 5.11. I think maybe okay. Maybe even before that. I think I always use it, so I don't really know. But yeah. So yeah, we can see that we have a good-looking car now. In fact, I applied a different material on each element. So if I swap on each, I go on each pipeline object that I have, we can see. Oh, sorry, I'm not on the good panel. Here I can see that for material I have, for example, plastic white material for my interior. For my windows, I applied a glass thin material. So you have you can do already a nice visual like this one, I think, with all basic materials that you have on that are shipped with ParaView. Now, before we dig a little bit further in materials and how to edit them, I will just show you how you can mix scientific visualization with visualization of scientific data with realistic rendering. So for example, say that we want to see and to color a certain field of the front of the car. So we can do that, but things that we can't is we can't show at the same time materials and colors. So in the front of my car, I will just disable material by selecting none here. So we can see that the front of our car is now white, sorry. And here we can now select a field, so for example displacement, and we can color and see data on particular parts if we just choose to have no materials and select a color. And the ray tracing will also work on this surface and show you a nice way your data. So if there is no more question for this part, I will go for the material editor. So a current limitation of the material editor for now is that it's not available in client server mode. So I will disconnect to my current server and show you this locally. So I have a state file that is already available to show that. Okay, so here we just see a wheel. It will be it's a smaller dataset, so it's convenient to show you that. So what we have in ParaView is a material editor. So what is a material editor? It's an editor that allows you to two things. First, it allows you to edit your materials if you want to customize them, and the second important feature is that it allows you to pre-visualize your material, the edition you are doing on your material before applying it on your model. Because applying it on your model, if it's a big data, if it's a lot of data, it can take a lot of time. So to keep reactivity, and we have this preview mode. So you can preview them by using the show shader ball parameter here. So here we can see, for example, the checker alpha material that is represented in the sphere, and we can see that it's a small scene, so it's interactive. And so I will demonstrate now how to use it to apply material and to customize them. So first I will show you how to attach a material on your data using the material editor. So I will go on the tires. And here I want to have a nice looking surface for the tires, so I will go I will check for available material, but I see that, let's say that we don't have materials that we want available for the tires. So one good thing that can be done is Material Editor allows you to load new materials that you can have available on your machine. Materials are available in can be described by a JSON file that describes all surface parameters. So we have one to demonstrate that. So let's click on Load Materials. And here I have the JSON file that is describing all the materials that I need. So I will click on it and click OK. So here we have several warnings because it's possible that ParaView do not yet support some parameters depending of materials, but we already support a lot of them. So there are only two that are not available for now. So NS and TF. So I just close this one. And now if I scroll back, I can see that I have new materials that appeared thanks to JSON I loaded. So I select tires principles. I can see already what it looks like. So it's a black flat material. And now what I do is click on attach, and it will apply it on my current actor that I selected in my pipeline. So now,
just before we can continue, yes, sorry for this inconvenience. You don't see in during the stream when we each Dropbox list, like the list of all materials. It's only an inconvenience with our actual stream setup. But yes, you have in ParaView a list available of all of these materials.
Yeah. It's when I open the file, maybe
yes.
We didn't see that.
Yes, when you open the file, and also when you click, for example, in the tires principle in the Dropbox list.
Okay.
When you click on this Dropbox list.
Yeah, it doesn't show in the. Oh yeah.
Yes.
I can show you just what it looks like by full screen. Here, when I load, we have I loaded this JSON file, and after that I selected it in this drop-down list. I will just swap on the ParaView mode. So okay. So now let's maybe I will stay with that for this. Sorry. Okay, it will be better now. So I will now show you how you can edit your materials if you want. So let's go on the rims. So maybe we will have some glitches with the rendering because it's our setup that if we show you the whole screen, we can have some glitches. So just to show you how to load. Oh no, I don't need to do that, sorry. So I will just swap.
Yes.
So maybe it will be better. So sorry for that. So now I will edit a custom material for my rims. So what I will do is create a new material. So I click on that. So yeah, we can see that. So I will just swap. I click on the plus button, and here I will be able to create a new material. So we have different materials types like alloy, car paint, glass, etc. So all these presets are described in the Intel OSPray documentation. So I advise you to take a look at that because it's very complete documentation that explains how material works and what each parameter corresponds to. But for now, I will select this one because it's a very convenient metallic-like material that is, that fits well with the rims. So I will name it, for example, rim alloy. Okay, I will click OK. So I will just swap. So now that I want to edit this material because this for now it's not what I want. So let's say that I want to edit the color, so I can double click here. And for example, I want a more grayish material, so I will, for example, select this color and click OK. So now we can see already the difference in the interactive view here. But the surface is not what I want, so I will modify the roughness, for example. So here I will modify it and go to 30, for example. Hit enter, and yeah. So here we can see that we have now a better looking material that looks like rough metallic material. And say that we are satisfied with that, so now I click on attach button and it will attach on our view, and we can see now that we have a wheel that looks like more like a real wheel. So yeah, and one important thing with the material editor is you can save also that everything that you already edited, so all these materials are contained in one single JSON file, so you can save the JSON files by clicking on the Save button here in order to let it available for your future uses of ParaView. So that's it for the presentations of Material Editor and OSPray. So I will just show you quickly an animation that we made with the materials. So let's show the whole screen and go to the video. Yeah, so this is a video that we generated with every material that I showed you today. So it's only default materials in ParaView. And we can already have a nice looking car crash simulation here. So to render this, it takes about maybe more than 1 hour, yes, I think, with a 15 time step and interpolation between them. So that's it. Don't hesitate. We will still have some time if you have any new question. But to summarize what we have seen, so we have seen how to enable ray tracing in ParaView and how to do a particular focus on OSPray and materials, show you how to apply materials on your surfacing data, and how to use the material editor to edit them.
So we have one question from Alex. Does it support LS-DNA results for post-processing and rendering? I don't know if you know.
No, sorry, I don't know what is LS-DNA. Sorry.
Yes, but Eric says that it can be done in OpenRadioss. We also have another question from Luis.
Yep.
Can we use the GPU to speed up ray tracing?
So I think that for Intel OSPray, GPU ray tracing will be available in the latest version of Intel OSPray, but maybe only with Intel GPUs that are dedicated for that. But if you want to leverage your GPU to do rendering ray tracing, you can also use other backends, for example, NVIDIA Index or NVIDIA Optics with NVIDIA GPUs. And but for example, for NVIDIA Index, it's available in a plugin that it's shipped with the binary version of ParaView as well. So I invite you to try it. Yeah.
Okay. Maybe one last question. Yes, regarding background image. Do you know if it's possible to rotate the background image? Because by default in ParaView, sometimes we have a different rotation than what we expected. So
yeah, so you have two ways to do that. I can maybe show you with ParaView if I just keep full screen mode. So here in the view panel, you have environment north and environment east parameters that allow you to rotate the HDRI, that is the background image that I use, but it's only available for now. It's only available for the ray tracing. If you want to do that with the standard skybox, that it's for standard rendering technique, you will not have access to that for now. The other way to do that, a workaround, is to in fact apply a transform filter on your scene to rotate the scene instead of rotating the background.
So yes, we don't have any other questions. Just yes, we can specify that yes, LSDNA is more likely linked to the input. So I believe you need to, if you want to use this type of solver, you probably need to extract it in a supported format in ParaView to be able to use it. We don't have any other questions, so
okay,
we can finish.
Yeah, let's go back to the slides. So sorry for the little technical problems we can have with swapping between scenes, but yeah. So thank you very much for attending this webinar. I hope that you liked it. So there will be other webinars that will come. So we will make announcement in our LinkedIn. So if you are interested to attend other webinar like this, stay tuned. So thanks for watching again. Just as a reminder, you can we provide services like training, support, and development. So if you are interested with that, and if you have any question related to this webinar, don't hesitate to contact us, and we will be very happy to answer you. So if there are no any more questions, thank you very much, and see you next time. Stay tuned.
Bye.
Bye bye.